Hello guys, my name is Balakrishna Srivastav and welcome to Code with BK. So in this video, we discuss how to insert a new node at the front of the linked list in C programming. So before we begin, it is a request to please subscribe to my channel, and if any of my previous videos or if this video helps you out, so please do subscribe to my channel. So in this video, we look at the concepts that go behind inserting a node at the front of the linked list in C programming. So in the previous video, we discussed what is a linked list in C programming. We saw what a struct node is. A linked list is basically made up of node objects. We connect multiple node objects to get a linked list. In C programming, we create a node object using a struct node, and we connect two struct node objects using struct node pointers that is within the struct. Okay, we also understood what goes behind the scenes, and then we saw how to print the linked list. Okay, in this video we understand how to insert a new node at the front of the linked list. Okay, so for example, if we have a linked list, say 2, okay, and we also discussed that this is how we are going to represent our linked list, where each circle represents a node and the value inside it in the circle represents the value inside the node. We can have a linked list of any data type. The value here that you have is an integer. You can have any other type of value. You can have a struct value as well inside here. Okay, and then head is the most important part. It is basically the variable that stores the linked list, points to the first node. Then from this node you can go to the next node using the next, then to the next node, and like this the next of the last node has to be null. These are the properties of the linked list. Has to stay invariant, has to stay constant before and after all the operations on the linked list, and this is how we visually represent the linked list. Okay, so suppose if I want to insert a node, say x equal to a node with a value x equal to 64 at the front of this linked list, so what happens is insert x equal to 64 at front. Okay, so what I want is 64 is my first node because I'm inserting this at the front of the linked list, then 2, then 33, then 8, then 100, and then 97, and then null. Okay, and my head is now at this new node because head will always point to the first node of the linked list. Okay, so whenever you are updating the head, changing the head, removing the head, adding a value at the front of the linked list, making changes at the front of the linked list, you have to take care that head stays at the first node of the linked list. Okay, so there are operations where we have to remove the first node of the linked list. In that case, head goes to the second node. Okay, always make sure that your head points to the first node of the linked list. Okay, so this is a problem description. Now how do we do this? Okay, we look at the previous video that we discussed, right? We created 5 node objects like this. Okay, and we connected them using their links. Okay, using these pointers. Okay, and then we were able to get the head, which is basically the first node. Head pointing to the first node is the node pointer, and then we print the list. Okay, so first I'm going to demonstrate using the behind the scenes memory diagram that how do we insert at the front. Okay, then we write a separate function to basically insert a new node at the front of the linked list. Okay, so the function signature will look something like this. Okay, that I have to return the updated head, and I'll say insert at front. Okay, takes the head of the linked list in which I want to insert my new node with the given value x. Okay, for now it is going to return null, or you can just comment this out. Okay, so this is the function signature that we do after we understand what goes behind the scenes. Okay, so following this, that we have 5 node objects and we are setting their corresponding x values and the next value, so we get something like this. Okay, so we made 5 struct node objects, and I'm just writing node because I'm using an alias. So instead of writing this struct underscore node, I'm just going to use the word node, and this is using type def. It is used to give aliases. I discussed this in the previous video, right? So whenever we create struct objects, they get memory for their corresponding members. So memory for x and memory for a node pointer to store an address. Okay, so n1 gets x and next, n2 gets x and next, n3 gets x and next, n4 and n5. Okay, and we are setting the x values of n1 as 2, x in n1 is 2, x in n2 is 33, similarly 897 for n3 and for n5, and then we set n1 dot next is ampersand n2. That is, the next variable inside n1 will store the address where n2 is storing. Next variable inside n1 will store the address where n2 is storing, basically being a pointer to n2, so that from n1 you can go to n2. You do n2 dot next, n1 dot next, you go to n2. Similarly, next of n2 will store the address of n3, next of n2 will store the address of n3. Similarly, next of n3 will store the address of n4, and then n4 dot next is n5. That is, the next inside n4 is storing the address of n5, and n5 dot next is null because the next of the last node has to be null to demonstrate the end of the linked list. Okay, all right. And then we did this. Okay, we did this because head pointer will always point to the first node. In this case, we have a variables for all of our structs. Okay, but when we have functions like this to insert node at front end and middle, we use dynamic memory allocation to create struct objects. So we get memory for structs, but we don't have a variable that is pointing to that memory. Okay, that is why we use pointers. Okay, so head pointer will always point to the first node. That is creating a variable. The name of the variable is head, is of type node pointer, pointing to this n1. Okay, address of stores the address of n1. Okay, so this list basically is stored like this in the memory, right? So if I want to insert 64, my head should point to 64 and the next of 64 should point to 2. Okay, so I create a new node. Okay, I say new node. Okay, struct new node gets its x part and next part. Okay, creating a new node, setting the x value to 64. Okay, and we don't know what there is in next. So this is basically in our code doing add a new node. Oh, let me just copy this to the new file and then make changes. Okay, so here. Okay, so I say node new node and then say new node dot x is 64. Okay, creating the new node, setting the x part, and then setting the next of 64 to 2. So the next inside this new node struct is going to store the address where the current head is. Okay, so the next inside now new node has to point to the original head, which is this n1 node. Okay, so head is storing the address of n1. So next in new node also has to store the address of n1. So next in new node also has to store the address of n1. Okay, you can say this or you can also say this. Okay, because our head is pointing to the first node. Okay, when you do this, the next here now points to this. Okay, right now both head and new node dot next are pointing to n1. Okay, but now 64 is our new head, so we say head is now address of new node. Okay, when you do this, this head was pointing to this n1, storing address of n1. Now this head, this is deleted. Okay, this head now stores address of new node, that is, it is a pointer to this node. Okay, right? So in order to get from this to this, let me just draw this linked list again. Okay, so in order to insert 64 to the front of this linked list, in order to get this, we said create a new node with the value 64. Okay, set the next of this new node to the original head, which is this, and then make the original head point to this. So we get this one. Okay, head 64 233 897 null, head 64 233 897 and null. That's how you insert at the front, and this is how you will usually find it in places. This is how it is represented in the memory diagram, that you have a node being inserted at the front. Behind the scenes in the memory, it goes something like this goes on. Okay, now when I print my linked list again, okay, you see 233 897 null original list, and then we inserted 64, so we have 64 inserted at the front. Okay, so this is the concept that goes behind inserting a new node, that you have to create a new struct, points its next to the original head and update the original head. But in this case, we already had 5 nodes here. Okay, all we had to create a new node, a variable, a new node, set the value, set the next, update the head. Okay, you will not always have this case, because we barely have a linked list where each node has its own variable. Okay, nodes in a linked list in C programming that we usually work with are all dynamically allocated and then freed. Okay, in that case, you don't have separate variables for each of those nodes. Okay, so you have to use next starting from head in order to reach the ith node, any node in the linked list. Okay, so now we move on to the part where we write a function to insert a new node at the front of the linked list. So we need to complete this function. Okay, so in this function, in your arguments, we have head, which is the head of the linked list. So whatever linked list you are passing, I told you head will store the linked list. It stores the first node of the linked list. So whatever linked list you are passing its head. Okay, and then you are also passing x, the value to be inserted at the front. Okay, create a new node with this value inserted at the head, and then return the updated head. Okay, all right. So this function will take the linked list and the value to be inserted at the front, and then return the updated head. Okay, at the end of the video we'll see why is this not void and why is this node pointer. Okay, I'll explain that you have to return the updated head. If you don't return the updated head, your function will not work the way you are expecting it to. Okay, so null basically is all uppercase in C programming. This is not gonna work. Okay, so it has to be all uppercase, and in my explanations at times I use lowercase. It just means the same thing. Okay, so let me just quickly write the code for this function, and then I'm going to insert values at front so that we get the exact same linked list. Okay, we get this first 233 897, and then we insert 64 at the front. Okay, and I'm also going to explain how we get the exactly same diagram. Is just that all these nodes that you see, okay, as local variables are now dynamically allocated. Okay, so you don't have a separate variable name for each of these nodes. All these nodes are dynamically allocated, and you can reach the node using the next pointer. Okay, so the first thing, if the head is null, okay, that is if your linked list is empty, there is no node that the head is pointing to, it means there is no node in the linked list. The linked list is empty. I say my head is now, I'm going to dynamically allocate memory. I'm going to say, okay, that is the linked list is empty with 0 nodes. So if the linked list is empty and I have to insert at front, it means you are adding the first node. So you say head is now node pointer malloc size of node. Okay, you set the value x inside head to the past value x, and you set the next to null, which is very important. Okay, because this is the only node in the linked list, that is why we are setting the next of this node to null. Okay, else, okay, if the head is not null, else if the head is not null, that is there is at least one node in the linked list. Okay, else if the linked list is not empty, is the case what we did here. We create a new node, set the next of this new node to the current head, and then update the head. Okay, so we say node new node equal to, okay, set the x of new node to this value x, set the next of this new node to the current head, okay, and update the head to current node. Okay, that is what we did here. If you remember how we created this diagram, we created this new node first, then we made next of this new node to current head, and then we updated the head. Okay, and finally we return head, which is the head of the updated linked list. So in short, if the head is null, that is if the linked list is empty, you create a new head and you return the new head. Else if the linked list was not null, there was at least one node, you add a new node at the front of the linked list, you update the head and you return the head. So in either cases, we are updating the head and so returning the head. Okay, so now let me just comment all this, okay, and insert. Okay, I'm gonna start with my node head equal to null, because when I start my linked list, it is empty, it has nothing. Okay, then I insert values 233 897. Okay, I'm going to say head equal to insert at front, okay, head, and I start with 2. Okay, then I do 33 897, 33 897. Okay, so if you insert in this order, the linked list is going to be in the reverse order of what we have discussed. So let me just compile and run. So initially we had this, we'll get the reverse. You see, we get 97 first, then 108, 33, 2. This is because you are inserting at front. Okay, so when your head is null, your linked list is basically null. Okay, when you insert at front, you insert the first node, so you get 2 and then null. Then you insert at front again. So now front is your new value 33, then the remaining part, which is 2 and null. Similarly, when you insert 8 comes at the front, okay, and then the remaining part. Again, when you insert 100, 100 comes at the front and then the remaining part. Similarly, when you insert 97, 97 comes at the front and then the remaining part. That's why you get this. So if we want our original list, I'm going to reverse my order. I'm going to say 97, 100, insert at front, insert at front, insert at front. Okay, I'm going to comment this out. Okay, this was just for understanding. Okay, now you see we get the linked list in our original order, 233, 897. Okay, and you see there are no separate variables for each of these nodes, 233, 897, the way we had here, N1, N2, N3, N4, N5. Okay, all I'm doing is I'm calling the function with the value that I want to insert and I'm getting my updated head. Okay, and if I keep printing after I insert each values, you see I get the updated list. So now clear, compile and run. So after inserting 97 at front, then 100 at front, then 8 at front, then 33 at front, then 2 at front. Okay, so now how is this actually working? So you will see this code, this piece of code basically creates a structure like this that we have discussed, that creates a linked list and then inserting at the head. Okay, so let me just create a memory diagram again. Okay, all right, so running this code and explaining how things work behind the scenes. Okay, so in my main I just have one variable head. Okay, so in my main I have a variable head of type node pointer and it is a part of main function because it is a local variable in this main function. Okay, and then you call this function head equal to insert head 97. Okay, when you are doing this, this function gets its own set of variables. Okay, so it will get its own head and its own x. That is, in your memory you get another memory to store head, okay, which is of type node pointer. This is the part of insert function, not writing the inside in entire insert at front. Okay, this variable head is a part of insert function, and since the head in our main was null, when we are calling this function, the value is being copied, right? So whatever value this head is storing, the same value this head will also store in insert, so it stores null. And this function also gets, okay, a variable x of type int, and it is also a part of insert. Okay, so this is a variable in the main, calling the function insert, so insert gets its own head and x, and we are inserting x equal to 97 first. Okay, so this x gets 97. Yeah, okay, so the values that we need to insert are x equal to 97, 100, 8, 33 and 2. We are calling x equal to 97 first. Okay, right, so we are here right now. Okay, in my main we just had one variable head calling this function. Okay, so we are here right now. Head and x are two variables in insert. Now we check this condition if head equal to null. So wherever the head is being used in this function is the variable for insert function. This remains untouched because it is a part of the main. Okay, we are inside insert function. Okay, so if head equal to null, so I'm going to write this condition head equal to null. Okay, head is null, condition is true. Okay, so you come inside this, say we say head equal to this node malloc size of node. Okay, so now head will point to a dynamically allocated memory of type struct node. So this head, rather than pointing to null inside insert, will now point to a dynamically allocated memory of struct node, so that it gets its x part and next part. Okay, both we don't know what it contains. Okay, then you say head.x is x, that is the x inside the node pointed to by head, okay, is now 97. Okay, this value x, and you say head.next is null, so this is null. Okay, so in this, if you created a dynamically allocated struct node, you set the x value and the next value. Let me just make it clear, right? This head inside node pointer is pointing to this node. Okay, and then you say return head. So we are basically returning the value which is contained in the head, which is being set to the head of this main. Okay, so you are returning this value, that is address of whatever this. So if this is at address addr1. Okay, so this head is storing, okay, this head is storing addr1. Okay, when you return head, you are basically returning the value in the pointer, which is addr1, which is being copied to this head inside main. So now this null, okay, becomes addr1. Okay, which means this also is a pointer to the same struct node, dynamically allocated. Okay, so that is how we insert the first node when our list was empty. So head was pointing to null, the list was empty before the function call. You inserted x equal to 97, that is head is pointing to this first node, the next of which is null, and it contains the value 97. Okay, very similar to saying the first step when you insert 97, head was null, you created a new node and you said head now points to 97, the next of which is null. Okay, 97 is inserted, and when the function returns, okay, because we are returning the value in the head, when the function returns, all local variables of insert node are lost. So this is lost, this is lost, this is lost, this is lost. Okay, so there is only one pointer, okay, to this dynamically allocated struct, which is head in the main. Okay, all these are lost. Okay, so after the first function call to insert the new node at the front, the head in the main is pointing to this dynamically allocated struct node. The value inside is 97 and the next is null. Okay, you have inserted 97. Okay, your second is insert 100. So now you insert 100. Okay, that is, you're calling this function insert at front with head and 100, calling the function with head and 100. So the value inside this head in the main is copied to the variable head inside insert. Okay, so head inside insert gets now addr1, which is a pointer to the first node, and the value of x is 100. We are here. Head equal to null is now false because this head pointer is pointing to this first node. So this condition is now false. Okay, it was true, it is now false. You come to the else part, you say a new node is dynamically allocated. That is, you get a new node with x and next part. Okay, whatever values are inside we don't know. Okay, and this is pointed to by new node. So we have a variable new node, okay, pointing to this dynamically allocated struct. Okay, we say new node dot x is x. The x inside new node is now x, which is 100. Okay, and then we say new node dot x is head. So the next inside new node points to where head is pointing to. Next inside new node points to where head is pointing to. So this head inside the function is pointing to this. So this also points to this. Okay, then you say head equal to new node. So wherever new node variable is pointing to, head will also point to that. New node is pointing here. So now this head inside insert points to this node. Okay, right? So the links we lose is we don't have this anymore. Okay, new node is pointing to this dynamically allocated struct. The next of this is pointing to the original head, and the original head is now pointing to this new node. Say this is addr2. So addr2. Okay, and when you return head, the value from this head is copied to the head in the main, because that is what we are returning. Okay, the return value of this function is head from the function, which is copied into the head of the main. So this is now addr2. Okay, addr2, where the second struct was dynamically allocated. This is addr2. So this is no more a pointer to this. This is a pointer to this. Okay, and since the function returns, we lose all the local variables. This is lost, and this is also lost. So this link is also lost. Okay, you're only left with this part in the main when the second function call returns. Your head in the main stores addr2, which is the address where the second struct was dynamically allocated, the next of which is pointing to the first dynamically allocated struct. So the linked list goes as head 100 97 null. So what we did was we created a new node 100. Okay, the next of which was set to 97, and now head was made to point to this. So it is head 197 null, and we inserted 100. Okay, so you see how the list was empty, and then we added the first node. So the list got the first node, and then the list was not empty, and then we added another node. And then for all the other three cases, this else part is going to be called. Okay, so let me just add one more value and show. So if you go to insert 8, okay, so you got to insert 8. All right, inserting 8, calling this function with head and x. So head is a node pointer inside insert, copying the value from the head in the main, which stores addr2. So this is a pointer to this location as well. Okay, also the function gets x, which is of type int, stores the value 8. Okay, we are here. Head equal to null is false. Okay, head equal to null is false, we come here. So a new node is dynamically allocated. So we create a new node. So a variable new node, okay, of type node pointer, okay, inside insert function, okay, storing the address of this new dynamically allocated memory, say addr3. So it gets is x and next part. Okay, you set the x to x, which is 8, and then you set the next to head. Okay, so whatever value was inside head is being copied to next. That is saying next will point to where head is pointing to. Head is pointing to this, so this next will also point to this. Okay, because head in our insert function is pointing to this. Then we say head is new node. So now wherever new node is pointing to, head is going to point to. So new node is pointing to this, so head inside the function also points to now this. Okay, so this link is lost. Okay, so after this statement, head also points to new node, that is this head also now stores addr3. Okay, head in insert now stores addr3, function returns. So whatever value was inside the head of insert front is being copied to head in the main. Whatever value was inside head in the insert front is copied to head in the main. So this becomes addr3 also. So this also points to this node. Okay, all right. Function has returned. We lose all local variables. We lose this, and we lose this. Okay, so what remains is head in the main pointing to this struct, the next of which is pointing to this struct, the next of which is pointing to this struct, the next of which is null. Okay, so we lose this local variable, we lose x as the local variable, we lose this. Okay, since we lose this link is lost. Since we lose node, new node, this is lost. Okay, and add3 was pointing to this, now points to this. All right, so when function returns after the third call, we have inserted 8 at the front. So after the third call, okay, we had 8 at the front, and that is how we are inserting a node at the front of the linked list. And you can see there is so much similarity between these two diagrams. Head pointing to the first node, then next, then next, then next, and next, and next, and next. Okay, so it keeps going to the next node until the next of the last node is null. Okay, and to demonstrate insertion of 8, we created a new node, next of which is the original head, and now head points to this 8. So it basically is equivalent to saying head 897 and null. Okay, head 897 null. Okay, again to mention that I'm showing everything in the same diagram, but all local variables, okay, all local variables, for example head and these variables and this head and x, they all are in stack memory because they are local variables. All dynamically allocated memory goes from the heap memory. Okay, this video went too long, but one last thing is, why do we have to return head? Okay, what if we don't return head? What if we don't return a head, and suppose if I have to insert 33? Okay, again I have 33 inside x, I have this addr3 inside my head in insert. Okay, so this is pointing to this. Okay, in this case I'm not going to return the value. Okay, we create a new node. Okay, variable new node is a pointer to this dynamically allocated struct with x and next part. We are setting x to 33 next to this node, and then we say head is also pointing to this. So if this is addr4, head stores addr4. Okay, head stores addr4, so this now points to this. Okay, we are here, okay, head in the function points to this, and then we don't return head, we just return. When we return, this head is still pointing to addr3. The value in this head variable inside the main has not been updated to the new head. So when the function returns, we lose this head, this x, okay, this local variable, okay. And since we lose this head inside insert, there is no direct reference to this struct, so this is a memory leak too, okay, dynamically allocated, but there is no way you can reach this. The next of this is addr3, which is the head in the main. You can reach this from head, you can reach this from head.next, you can reach this from head.next.next, but this is a memory leak, and head is still pointing to the old head, so head is not updated. That's why we have to return head, okay. And if we don't return head, the list will always be null, because in the first case, if I do the same thing but I don't, okay, so printing after each insert, you see we get empty list only, because I'll tell you why, okay. Because, right, if you remember, in our first case when we were inserting into an empty list, this is my head inside my main, okay, calling the function, so the head inside insert, okay, also is null, and we get the value x. What was the first value of x that you inserted? 97, okay. This is x in insert, okay. Since head is null, okay, since head is null, we created a new dynamically allocated memory for head. So we say head in insert is now pointing to a new memory location, so we lose this, okay. It gets at address addr some value, I'm just a variable name addr1, pointing to this dynamically allocated start with x and next, okay, setting x to 97, okay, setting the next to null, okay. We are here, and then we return, we don't return any value. When we return, we are not returning any value, so we lose this variable, okay, and this head remains null. It is when we are returning the value, we are overwriting the value in this variable to the updated head, in this case the way we did here, okay. When we don't return the head, this value in the head in the main, the value in the head in the main remains null and it does not change, okay. So you have to return head in order to reflect the changes made in this function, okay. That is why, that is only we get the updated head, okay. Running this again, okay. I hope this is clear, and similarly you can insert further values, okay. All right, so I hope this is clear. So when you compare this with this, you understand we just had variables holding all these struct nodes, and then we connected them. In this case, all these struct nodes are just dynamically allocated, okay. You should be freeing all this memory, and we see by the end of this video series how do you free memories of structs that are dynamically allocated, okay. So this was to insert a node at the front, and I'm usually going to use a diagram something like this, okay. Maybe one or two more videos to explain how things work behind the scenes, and then we go through a visual understanding using a diagram like this, okay, circles and arrows, okay. All right, so this was to insert a node at the front of the linked list. We now see in the later videos insert at middle, insert at end, then remove operations, okay, and then if want to insert in sorted order, okay. So I hope you like this video and this was helpful. So if there is any doubt, there is a part you do not understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there is a question you want to solve or if there is a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.